Hello, 7th graders. Today's lesson is going to be an introduction to rational numbers. In today's lesson, you're going to have some important vocabulary, such as integers and absolute value. Okay, so let's start with integers. Integers are all positive and negative whole numbers. So this definition says the set of whole numbers and their opposites. Opposites are positives and negatives. So positive 1 is the opposite of negative 1. Negative 3 is the opposite of positive 3. So integers are all positive and negative whole numbers. Let's add that into our notes. All right, a rational number is a number that can be written as A over B, or a fraction. In the word rational, we see the word ratio. So think rational ratio, which is like a fraction. Rational numbers can be written as a fraction. All right, let's investigate this concept a little bit. Pretend we have a number line on the floor. On this number line is both positive and negative numbers. If you were to stand on an integer and then someone else stood on the opposite, so say you're standing at 1 and your partner then stands on negative 1, how far are each of you from 0? You would both be exactly 1 unit from 0. Now, we're going to learn on the next page that this distance is actually called absolute value. For now, I want you to notice that opposites have the same distance from 0. All right, we're going to skip number 2 for the video. We might do it in class in person, but a little hard to do over video. Okay, so say we were standing on any number other than 0. Let's pick negative 5. Can your partner stand on a number that is greater than your number and farther from 0? Yes, they could stand on, say, 10. 10 is greater than negative 5 and farther from 0. Okay, greater than your number and closer to 0? Yes. Negative 2, negative 1, negative 3, all of those are greater than negative 5. They are further right. That's a good thing to note here. Greater is going to be anything further right and closer to 0. And then less than your number, the same distance from 0. No, because we chose a negative number. The number the same distance from 0 is positive 5, and that's greater than negative 5. Okay, less than your number and farther from 0? Yes. If we went any further negative, so say we did negative 10, it's less than our number and further from 0. All right, here's that second important vocabulary word. Absolute value is the distance between a number and 0. You will notice that positive and negative numbers that are the same, so they're opposites, have the same distance from 0. Opposites have the same absolute value. Okay, for our first example, we're just going to start off by finding the absolute values of numbers. So find the absolute value of negative 3. Well, negative 3 is right here. It is 1, 2, 3 units from 0. The absolute value of 1 1/4. 1 1/4 would be like right here. It is 1 1/4 units from 0. Notice that these are both positive. So a trick to absolute value is you can actually just take the number and make it positive. Not opposite, because positive numbers still have a positive absolute value, but absolute value will always be positive. So pause the video, write these 3 absolute values, play it back, see if you got them right. 1 should be 7, 2 should be positive 5/3, 3 should be positive 2.6. All right, the next thing we're going to learn today is comparing rational numbers. So that's deciding which numbers are greater or less than. We might be using these inequalities, if you remember what those mean. The one on the left means less than. It points to the smaller number on the left. And then on the one on the right means greater than. It's pointing to the smaller number, which is now on the right. So less than, greater than. Okay, compare negative 1 and the absolute value of negative 1. Well, the absolute value of negative 1 is positive 1. Negative 1 is here, positive 1 is here. Because negative 1 is further left, Negative 1 is less than positive 1. All right, absolute value of negative 0.4 is just 0.4 or 4/10. Absolute value of 0.2 is still going to be 0.2 or 2/10. So 0.4 is right here, 0.2 is right here. Because 0.4 is farther right, it is greater than 0.2. 4/10 is greater than 2/10. All right, absolute value of negative 2.5 is positive 2.5, which is right here. And then 3/2 is also 1.5, which is right here. So absolute value of negative 2.5 is greater than 3/2. If this were not absolute value, it would be farther left being negative, and then it would be less than. But because it's absolute value, it's positive, and now it's further right. All right, pause the video, see if you can fill in the blanks for these two, play it back to see if you got it right. All right, absolute value of both positive and negative 9 is equal. Those are the same. And then notice this negative outside the absolute value, which means it actually stays negative. So that is still a negative 1/2. If we had a number line, negative 1/2 would be right here. And negative 1/4 would be right here. So negative 1/2 is further left, meaning it is less than negative 1/4. All right, last example. A moon has an ocean underneath its icy surface. The table shows the elevation of tests scientists run above and below the surface. Which test is deepest? Which test is closest to the surface? Okay, so in this table, you're going to see the tests. You have negative 3.8, negative 5.15, 0.3, negative 4.5, and negative 0.25. To figure this out, we're going to graph them on a vertical number line. So they put a number line over here. We are going to graph those. The surface of the moon is going to be at 0. Okay, so the atmosphere is the only positive one. I'm going to shorten it, Atmos, atmosphere. So that one is above 0. Let's see, temperature is negative 3.8. So that's going to be like here-ish. We'll say temp. Salinity is negative 5, just under negative 5. So we'll say that's right here. Salinity. Organics is negative 4.5. So it's going to be right between negative 4 and negative 5. Organics. And then the last one, ice, is at negative 0.25 or negative 1/4. So that should be right here. All right, so let's go back to our question. What was it asking? Which test is the deepest, which is going to be the most negative in this case. So salinity is the deepest. And then which test is closest to the surface? Well, the atmosphere and ice are both close to the surface. However, the atmosphere is 3/10 away from the surface, and ice is 25/100. Remember, 3/10 is also 30/100. I find it easier to compare these if they have the same amount of decimals. And we know 30 is bigger than 25, so 30/100 is bigger than 25/100. So the salinity test was the deepest, and the ice test is closest to the surface because 0.25 is closer to 0 than 0.3. All right. An airplane is at an elevation of 5.5 miles. A submarine is at an elevation of negative 10.9, which is closer to sea level. Sea level is 0, so the airplane is going to be closer to 0. All right, 7 says the image shows the corrective powers in diopters of contact lenses for 8 people. The further the number of diopters is from 0, the greater the power of lens. Positive diopters correct farsightedness, negative correct nearsightedness. So those of you who wear contacts, you might have noticed some numbers on your contacts. This is what those numbers mean. Kind of cool. Okay, who is most nearsighted? Nearsighted is negative. So who's most negative? Well, let's see. Negative 7.5. Looks like it's the most negative. Let's color code these. So 7.5 is the most nearsighted. Who is the most farsighted? Farsighted is positive. If we look at our positives, we got 2, 3, and 8. Greatest out of those is going to be our 2.5. So that's our most farsighted. And who has the best eyesight? That one's going to be closest to 0. Best eyesight is going to be closest to 0. The only one that even starts with a 0 is this number 2. So she has the best eyesight. All right, please see Canvas to see what your assignment is for today. This is the end of the notes video.